Welcome to Mastering Mathematics. Here's our instructor, Dr. Karen Wester.
Hello, welcome again to another in the series, Mastering Mathematics. This is a program sponsored by the Ministry of Education using its EBU unit, its Center for Mathematics Education, and ABS Television. Yes, we're going to make mathematics a doorstep experience, and we're still ticking because yesterday we gave you several theorems, all right, and sent you home and asked you to look at them. Today, I have gone straight to the 2013 examination CSEC paper, and this was the question they had to do for their number. It was a number 10 question, a choice in the measurement, geometry, and trigonometry section. Okay, and this is the figure that we have just transferred on the board. I'm just going to give you the salient points that they gave you in terms of reading this and then what they asked you to do. And we're going to walk you through, okay? Because you see these questions, and I'm sure, because we told you already, that when you see the O, you know you're at the center of the circle, and here, this is the circumference. And your brains just start ticking immediately because you say, I know theorem about, right? Center and circumference. Then what again we have, because we know the different parts of the circle, isn't that true? So you have 0B, and we have OA, so we know that there are two radii for the circle, and we know that the radii of the circles, that they are equal, so that because of this, we know that this line is equal to that line. And once that line is equal to that line, what do we know about the angles, Jetta?
Yeah, equal.
The base angles here, that we call them the base angles, they're equal, because if this is 40 now, this would be equal to 40 degree. And if that is 40 degree, what is this angle here equal to?
Should be 100 degree.
It's 100 degree, because what do we have? We have a triangle OBA. All right, so if we have two angles and the two angles add up to 80 degree, then the sum, any triangle, the sum is always equal to 180 degree. So that this angle here then would have, if we've given away 80 degree already, the portion left for this angle would be equal to 100 degree. Now, this is the angle at the center. And we have the letter F, the angle F at the circumference. What's the relationship between the angle at the center and the angle at the circumference?
It's twice the angle. The angle at the circumference is half.
Exactly. Yeah. The angle at the circumference would be half. And my little grade students, my primary school students, if we're saying half of something, what are we doing? Yes, I see that little hand going up and say, Mommy, I know that. We're dividing by 2. That is right. And when we're dividing 100 by 2, what is the answer?
50.
And it is equal here now that this would be 50 degree. Okay? And for those people who you think would not know, you ask them, if you have $100 and you have to share it with your friend and you have to give him half, how much money you have to give him? 50 cents. So he knows right away that half of 100 is equal to 50. Whatever it takes to be the association for them to learn the stuff, give them. Okay? Sometimes you say, mental test, it may be too hard. But if you tell somebody, if you have 8 apples and your uncle came and gave you 2 more apples, how many apples you have altogether? Okay. It's the same thing as asking them 8 plus 2 would be equal to what? Okay? So make it an association, especially in the primary schools. So we are fitting in the things, and we're not even reading the people's question first, Jetta. What kind of thing is this? You see, as soon as you look at the figure, things start jumping out of view, ain't it? Right, so let's read it first and see. It says the diagram below not drawn to scale. So this diagram shows a circle with center O, and EBC is a tangent. Now, what do we know? Because I didn't put it up there yesterday. What do we know about tangent and radius?
Well, when a radius meets a tangent at the circumference, they make a 90 degree.
Exactly.
Angle.
The angle with radius plus tangent is always equal to 90 degree. And then the radius cannot meet the angle anywhere else but the circumference, because the definition for tangent is a line that does touches the circle in one spot. Isn't that true? Okay, so here we have just introduced again number 7 for our theorems to say that the angle with the radius and the tangent is equal to 90 degrees. That is what we know right away. Okay, and everything else holds that you were told early on when you picked up your geometry. Angles on a straight line add up to 180 degrees, etc. Okay, and we can look, and so we have already identified the possible theorems that could be used to solve this question. Let's read you the question, my dear. Oh my, we got carried away. Here, the diagram, yes, shows a circle with center O. EBC is a tangent to the circle, and then they're telling you that OBA is equal to 40 degrees, and angle OBF, so OBF is equal to 35 degrees. Here, what they want us to do: 1, calculate, and it says, giving reasons for your answer, the measure of, and the first one is angle EBF. The second one is angle BOA. And the third one is 1, 2, 3, and it is angle AFB. And the fourth one is OAF. Okay. As soon as I'm writing these, I remember George Barry's daughter, Kayla. And she's listening right away. Hi, Kayla. Keep on looking at mathematics because you're going to be so very good. You're going to be in first form, but you're going to be actually as if you're doing fifth form work too, because you're listening every time. And all these little people whose name I have forgotten, yes, keep on looking, okay? Because you're going to say, that is so easy. That's how you're going to have it. Daddy, I can do that. Mommy, I can do that. All right? And parents, keep them close to you. Let them see. Challenge them. Yes, they can. All right? So, these were the questions that we were asked to find. And notice what we have done. You're not stopping and saying, okay, look for EBF. We're filling in all the angles we can first, and then afterwards we're going to go and read out what they're asking us for. So we have actually started because we were in twos that we knew that this was a radius, that was a radius, OB was a radius, OA was a radius, and therefore, and it was forming the triangle OBA, and therefore, because the radii are equal, we had an isosceles triangle. They told us that this angle was 40 degrees, so we knew that that would be 40 degrees. And once we have two angles for a triangle, we can find the third one, and then so this is equal to 100 degrees. Then we employ our theorem that says angle at the center is equal to 2 times the angle of the circumference, or we use the one that said angle at circumference would then be equal to half the angle at the center. So once we knew that this was 100 degrees, we knew that this had to be 50 degrees. What else do we know? This is, so every time, all the words that they give you in the questions, they have meaning and implication that you must draw out from that to solve your questions, okay? Now, what do we have here? This line is a radius, and it's going with a tangent, okay? Tangented B. So really, although CXC has given us OBA to be equal to 40 degrees, we know because we have radius, let's just do it in red so you can see, that line was the radius meeting this tangent, that part there. We know that that whole big angle must be equal to 90 degrees. Because we said the radius plus the tangent, where we get them meeting, they provide an angle of 90 degrees. So if we know that piece of that 90 degrees equal to 40 degree here, Jetta, what would the size of this angle ABC be equal to?
50 degrees.
It would be equal to 50 degree. 40 plus 50 would have given us the total of 90 degree, which would have been the full sum of this angle here. Okay, so that is how that was gotten. And then we look at the other side too, because this is still a radius, okay? And on this side, we have that this part here, OBF, is equal to 35 degree. So we know that this, again, is made up of this little piece and this piece to give us the 90 degree over here. Isn't that true?
Yes.
Because the tangent and the radius give us an angle of 90 degrees, and it's on both sides, all right? So if this is 35 degree, what would this angle here be equal to?
55.
So that is equal to 55 degree. And we're looking, because we would have said, we could have gotten it if we didn't remember to say 50 plus 40 plus 35, and to get that little piece, the tangent could be referred to as a straight line. Isn't that true? Yes, so the angles on the straight line will be supplementary, so we add them and take the sum from 180, and we'd have gotten that too. Now, do we see anything else we can fill in? No, because they have given us this angle OBF, we are suspect that something may come out. So look, do not be afraid to put in a construction line to say I can form another triangle here. So if I put this to go FO, okay, FO here, okay, we can get that and make this then a radius. This and that would be equal. If this is 35, this is 35 degree. But the whole angle is 50. So on this side of the triangle, this little piece over here would be equal to what? 15 degree. That is how we split them, okay? So if they ask you for OFA, we can find it. And this is an isosceles triangle too, so this angle up here would be in all another 15 degree. And then we can find that this one would have been equal to 150. Isn't that true? And 70 and 70 will give us, and this part here would be equal to 110 degree. So we have filled in everything that we really can get, okay? And that is how your diagram would look when you're finished, because you know the information and you're just fitting them in. Now is when you would go back and just read off the answers. The first one they'd ask us for was for EBF. So you follow it, and where is the E? Here it is, EBF. So take it out that you can see E, you have your B, and the F is up here. And what's the angle in here? 55 degree. That is what we got here, okay? And we can either say our reasoning complementary angle to tangent with radius, okay? Now here again we are asked to find BOA. Can we see that one? Yes, BOA, and that is the spread like the one like the ice cream cone here. And we have B, you have O, and you have A, and the angle in here was equal to 100 degree. Can be the third angle of the isosceles triangle for your reasoning too, but you can choose to see where you're going with your reasoning. And then we have AFB. Let's look at it again. So we have A, F, and B. A, F, and B. And what did we say that whole angle up there was? So because we're going A, and we went F, and then we came down here, B, and we went up here. So that's the angle at the circumference, which we said was equal to 50 degree. Isn't that true? Right? So angle at circumference is equal to half the angle at the center. And lastly, they were asking us for OAF. Look at it here. OAF. And we showed you how the splitting went on a while ago, so that we know that this is the angle OA. So we went O, and the A came over here, and the F up there, and we knew right away that that little angle was 15 degree. And again, the base angle of isosceles triangle OFA. And that's how we get our things, just dropping out like that, okay? So no hard anything. You don't look and say, oh, let's work out EBF, and then go, You fit in all the angles you possibly can on the diagram. And after that, you're just reading them off to show exactly what is. So we will let you get a little break. Now, when we come back, we're going to show you another one, okay? Another one. And this was from the CXC examination paper 230. Very easy, because we know of theorems, okay? So take your break, and we will have another one for you.
To succeed in mathematics, you need to build on what you've learned before. New concepts are added to and build upon previous concepts. It is very important that the early material be mastered thoroughly. Similarly, mastery of material from previous classes makes success in later classes more likely. So continually review and practice concepts from previous sessions.
Carefully read over the sections of your textbook assigned by your teacher and look carefully at the sample problems. Decide if you benefit more by reading before or after the instructor covers the material.
Madam Moderator, I will address the absolute impracticability from a financial point of view as Antigua and Barbuda being able to sustain a major disaster without outside help.
Collective national efforts have earned Antigua and Barbuda the reputation for being resilient.
Don't miss the 2015 edition of the Lime Inter-Secondary School Debates. Listen as students across Antigua and Barbuda debate many of the issues that affect us, be it education, sports, health, or the environment. We will dissect it for you. So join us Tuesdays 8 p.m. on ABS TV immediately after the evening news. We debate it, you understand it.
Violence against women and girls is not a problem isolated to certain homes or individuals. It is a community problem. The Directorate of Gender Affairs wishes to invite you to an interactive community town hall meeting to increase awareness on gender-based and sexual violence and to mobilize communities to positive change. There will be 2 opportunities to attend: Wednesday 25th March and Thursday 26th March from 6 p.m. to 8 p.m. at the Multipurpose Cultural Center, Perry Bay. Make it a family affair. Join the conversation. See you there.
Here at the Five Mountains Primary School, we take pride in being environmental patriots. We are planting trees. We are recycling. We are composting.
Be clean, be green, be vigilant is all the children ask. Environmental patriots committed to the task. A message from the Five Islands Primary School.
Join us for a new series of Mastering Mathematics, Mondays and Tuesdays, 6:30 p.m. here on ABS TV.
Right, so we're back, and you had your break. And now I have another thing on the board here for you, because yes, we're growing up and we are learning something. This time, this is the CXC examination paper 2014, and it says the diagram, not drawn to scale, shows a circle with center O, and then we have the line BC is a tangent to the circle, okay, at B. And they told us that angle CBD would have been equal to 42 degrees, and that OBE is equal to 20 degrees. And we are asked again to calculate, and they said giving a reason for each step of your answer, the measure of 1, angle BOE, 2, angle OED, and 3, angle BFE. So 1 angle BOE, 2 angle OED, and 3 angle BFE. Now, so all the theorems we have already. You see center, we see radii, okay, and we see angle at circumference. Now, there's one theorem I want to include for you today. I can call a line joining two parts on the circumference, opposite sides, that is a chord. Isn't that true? Yes. That we can have the tangent DCE, and we can have an angle here. And I want to say the angle between the chord, that would be equal to any angle in the alternate segment, because we have segment 1, segment 2, and then we say the angles in the angles are equal. So look at how I tell my students to remember this. The chord we would call like the foundation of a house, okay? And it is on that we build the house. So this is the roof of the house. So we say the angle under the house and that in the roof of the house, that they are equal. All right? So we have again the angle under the house and in the middle of at the roof of the house, that they are equal. So we talk about then, so if I had an angle A here, you would see that this is a chord, and so this angle under the house A will be equal to the angle at B up here. All right? So you just look and see where the apex of the triangle is leading, and we can get that, because I can assure you that we can see something like this over here, where we have this chord, and we can see this triangle EBD, so that this angle under the house here would be equal to the whole big angle up here, which would be 42 degrees. All right? Now, let us take it in pieces. So we see a triangle here, and we have an angle at the center. What type of triangle do we have, Jetta? This is an isosceles triangle, because OE would be equal to OB. All right? So if the angle at one of the bases is 20 degrees, what would this one be equal to? 20 degrees. So that is also 20 degrees, because the properties for the isosceles triangle holds that this is also 20 degrees. And then what is this angle up here equal to?
20 plus 20 is 40, minus 180 would be 140.
Right, so this is 140 degrees, because the angle for the sum of the triangle is equal to 180 degrees. Now, this again would be the angle at the center, isn't that true? Yes. And then, so this is the angle at the circumference. So what would that angle be equal to?
70 degrees.
So it would be equal to 70 degrees, half the angle. Okay, so this is equal to 70 degrees. Okay, what else do we know? Can we see we have a figure which is EDBF? So we have it touching at 4 points on the circumference. So what type of figure is that? It's a cyclic quadrilateral. And what do we know about the opposite angles for the cyclic quadrilateral? So they are supplementary. So if this is 70 degrees, this would be equal to 110 degrees. What else do we know? What else can we say? Can we find pieces anywhere? Yes, because we said that this was an angle under the house, and this whole angle up here would have been equal to 42 degrees. So if this piece here is 20 degrees, what would this part be equal to? 22. This would be equal to 22 degrees. Okay, that is how we work these things. Now, again, we can say, remember that this and that this is the radius, and it is touching the tangent. So the whole big angle here would be 90 degrees. So if this part is 42 degrees, this then would be 90 minus 42, and that would give us what? 4 from 7 leave you 3, so that this part is 38 degrees. That is how we're getting that. Okay? What else can we see? Can we see anything else here right now? Okay, so we pause for a minute and we look and we see what they're asking us. So here, the first one would have been BOE. And here we have it BOE. And what is the answer? And that's equal to 140 degree. Okay, because it's the third angle for the isosceles triangle. Okay, triangle, which was EOB. Okay, now what is OED equal to? OED. And you see it right here, we said it's equal to 22 degree, because again we said that the whole angle was equal to 42 degree, since the angles in the alternate segments are equal, but since a piece of it is 20 over here would have to be 22 to make up that 42 degree. And the next one they wanted us to show was BFE. BFE. And we see right away that BFE was equal to 110 degree, which is the opposite angle of a cyclic quadrilateral, FEDB, and we know the opposite angles that they are supplementary. And that is how the things drop out. All right? So the figures should not frighten you, because you know exactly that you know your theorems fit in what you know. When you get to a spot, you don't have to be killing yourself to say this, that, or something. Pause if you don't see anything else dropping out right away to make logical sense. And then, because this is not an isosceles triangle, these are chords, and nobody told us that they were equal, so we can't treat them like the radius. Okay? So we could not say that this piece and that piece we knew. We needed more information to get that. All right? So that is what, and then CXC just asked us for these three, so you see you're right there. So that is how you use the theorems, and that is all it's going to take. And what you have to do now is to practice, so you can get your same eyes, like what Miss Weston is using, Dr. Weston is using, so you can see the things, tear out the little theorems, say them, sit, do with somebody that say, okay, she knows them, let me go and let her tell me, so that we can have simulation and mentoring taking place. You're not cogging, you're not being disgusting. Call and ask, and you can get information. Don't forget that you can go to the website, masteringmathematics.info. Go to your YouTube again, because the things are right here. And we have done a topic like this because Miss Thompson did a lot of the geometry already last time. And now I'm just going over some of them and then doing the whole thing. Because yes, I'm having fun. So I hope you're having fun too in terms of learning. But apart from fun, I want to make certain you take your passport with you to the world. And mathematics is fundamental to everything you're going to require. And the first thing they're going to ask you, because you walk into the office and they see that you're speaking English, all right? So they're going to ask you, do you have mathematics? And make certain you can say, oh yes, I do. And I love it. It's a subject I have a passion for, all right? Because it's so lovely. And as long as you have your information, always think. Anybody say they have a problem, say, let me show you. Try and be enough and edge up and be the teacher when it comes to somebody showing mathematics, because you are going to be learning at the same time, and you will see what you don't know. All right? There's some lovely gentlemen outside there to sending their children to class. Next time I'll get all the names for you. But they are really passionate and really good. Tomorrow I go to Barbuda, and yes, we are going to continue because the Barbudans are coming and we are going to pass our mathematics. My primary school students, you weren't forgotten today, but we're doing something. And sometimes when I'm doing this sort of thing, you sit and listen too. All right? Work with your mommy, because mommies, you're not going to try and say, hey, but nothing too hard, let me go back to school. Jump on the bus and say, yes, I'm going to try mathematics. It doesn't have to be you're going to get money or get a stipend for it. What is going to be important is that you would have challenged yourself and say, so many years I didn't do it, and now I'll go back and I take it up. You will see money can't pay you for the feeling that you're going to get when you see, what? I passed this subject? I thought my little old brains couldn't do anything? Sure you can. So continue to make certain that you spread the news, and thank Mr. Serpent. Make certain you spread the news about mathematics on your television show, all right? And then let us talk sensible things, and let's make certain that we are indeed making our nation prosperous in terms of knowledge. It's the only thing we have got. And through the grace of God and His wisdom, we are going to conquer. So until next time, this is Dr. Karen Weston, and with Jetta and everybody at EBU, wishing you all the best. And of course, we'll be putting these things on YouTube and Facebook, so look and see that you have the latest. See you next time.
Join us next time for another in the series, Mastering Mathematics, a production of the Education Broadcasting Unit in the Ministry of Education and ABS TV.